And we're live.
Yay! Do you want to do an introduction, or should it just go ahead?
Oh, wait.
Just go ahead.
Cool. So, thank you very much for giving me the opportunity to speak to you on this Tech Talk. My name is Aarno. I'm the CTO and co-founder of Vision. We're a small 27 people company based in Zurich as well. We're about 3 blocks away from the Liip Zurich office. We're a young company. We were founded in 2014. And what we do is that we help developers run their web applications 24/7. And we do that, unlike other hosting companies, on any cloud, on any infrastructure. That means we take care of all the deployment, the monitoring, the backup, the metrics, the logging, everything that's software related. And our infrastructure partners, we call them cloud providers, take care of all the storage and compute and networking and all that's needed to actually make it, publicly available. And that enables us to use the same software tools and methodologies like continuous integration, continuous deployment, Git, to manage all of this. And we think that's awesome because that helps us to collaborate together with developers to make sure that the software that developers develop is actually happy because it has the right environment and the right backends to flourish. That's shortly about us and what we do. Traditionally, I'm going to speak a little bit about the ops to DevOps, what that means for us, and what kind of tools and processes and people around that, of course, we need to do that, which will be the introduction to how to or how we think applications should be built and deployed using software containers and orchestrated using modern technologies like Kubernetes. If you have any questions, please do ask whenever you want to, or of course at the end, and I'll try to be as quick as possible to come to the demo and also to be more interactive with you guys. I've been in the hosting industry for just over 15 years now, and a lot of the operations world has been firefighting as a service, has been reactive, has been painful. And that's why in 2014, when I co-founded Vision, I decided that we as an operations team, as operations people, we need to come closer to the developers. And coming closer to the developers means for me that we should be using the same process and the same tool sets as developers are using for the operations part. And so this is what we feel like a software deployment pipeline should, or software deployment process should look like, because we feel that this helps operations people like us to work a lot closer together with developers like you. Because we have the same process and we use the same tooling, it's a lot easier to do changes by pull request, for example, or to discuss on a common code. Hello? Oh, somebody unmuted, so I thought it was maybe a question. So you as a customer, as a developer, you of course code in version management. We all use Git for that. And then you can use continuous integration to test your code. And so that's exactly what we think is a good thing, and where we think that all the software environment management, so configuration management, should also plug in. So to have the configuration management, the description, what your software needs to run, what kind of application server, what kind of backends, all of that should be in the same version management as well. And unfortunately, I don't have a mouse pointer to point you at the configuration management bubble. But all that declaration should be, because that one should be versioned as well, just like your software. So a change in the PHP version is a change in configuration, which should be a feature branch like any other change in your software. And of course, if you have a description of what the software needs to run, then you can create a development environment, for example, on your laptop to try it out, so that you have actually the same configuration and the same environment on your laptop like on any server that you use. And of course, when using this kind of configuration management to describe your development environment, you of course use the same configuration management to describe your test and production servers. And with that, you never have the problem again that it works on your machine, but it won't work on the server or on the multiple servers. And so that's what how we think that development and operations can and should work together. Of course, providing these feedback loops so that when you change something in the configuration management, for example, PHP 7.0 to 7.1, then you can also try it out yourself on your laptop and then also deploy it yourself on a test and production server. So it should be a change like any change, and it should follow the change management processes like you do for your software. So, for example, also providing the feedback on all your team via team chat, or of course all the traditional operations processes like backups, but also all the service monitoring, alerting, logging, and metrics. All of this information should be available to give you the feedback loop on a dashboard or whatever, to have you or your customer, the product owner, make informed decisions about how to further develop the software. So how many users I have per minute, or how many francs of turnover my shop makes per minute, right? These are important data that you can take information out of. Now that we do for different customers. One of them is Liip itself. Um, we we say we take software and make a service out of it. So all the operation stuff. So for example, we run the gitlab.leap.ch for you guys, which we're very happy to do. Thank you for that. And also we work on the Pistor case together, which I'll come to you or show you in the demo section later on. So how did we do that before? Vision and the trailer before that, we managed a lot of complex web applications. This is going to be on a test. No, I'm kidding. This is an example of an application that's running in two different cloud regions, and with front end, load balancer, web application firewall, different application servers, and queue worker servers with Postgres and NFS in background. And so you see this is where we come from, right? This is the complex, high availability hosting and operation stuff that others do as well, but that we do on any cloud provider, but also in customer on premise. Now, the problems that we had 3 years ago was that even though they are virtual servers or cloud servers, they still take like minutes to hours if they're like a customer on premise and has to do manual changes. They take to spin up or to change or to get more resources, and even then, sometimes manual intervention is needed. But an autoscaler is very difficult and complex to do, even with virtual servers. And all the configuration management, which we've used Puppet and Ansible for, there's mostly server level, right? So it's a whole server that has a version of PHP or something, and not if there's like multiple deployments or multiple projects or virtual hosts. They're very difficult to have like different versions of PHP, for example. And also all the dependencies. So I'm using the version of PHP as the example, right? But it works for any config variable. They're managed by Puppet, and so it lies in the Git repo of Puppet or Ansible. And so all the coordination between the repo of the application and the repo of the configuration management takes, again, manual effort. And since it is so complex with multiple services and stuff, if you change something in Puppet, it affects multiple components, will be rolled out to multiple servers. There's a lot of moving parts and risk. And of course, it's another language, another descriptive language of configuration. So there's a lot of resistance to do that, to change that, and to actually collaborate with that. There's other problems like managing service dependencies at runtime. So start the application server just after the database is started. That's really difficult, actually. And also scaling up, so having like horizontal scalability, multiple application servers, that's, well, easy, it's okay, right? But scaling down, so to use less than 2 gigs of RAM, 2 gigs of RAM per deployment, that's actually really hard, because you always need like a whole virtual machine to run on. So it's not feasible to, for example, deploy for each feature branch, make a new deployment, because they actually cost money, right? They're like, I don't know, 100 francs per month or something per deployment. And so people start worrying about the cost, and then they don't do like feature branch deployments, and then you can't test your stuff except on 1 or 2 development environments, and then yeah, it's not really cool. And so we went out to find a solution for this problem. So what we wanted to have was like the whole build, ship, run workflow that you saw earlier, with the integration to CI/CD. I mean, that part's already there. We don't have to reinvent that. DevOps and self-service. So we believe that if you can yourself start something, build something, then you don't have to wait for operations. And since you don't have to file a ticket and wait for operations, you have actually more time to do new stuff, and we have more time to take care of the stuff and to make the services easier to use and easier to service. And of course, the isolation between the environments, whether they're projects or services or different customers or tenants, that's of course key, so that you don't accidentally access a production database from a test server or test instance. That has happened before, and so that's something we should not do, and it's like basic security stuff. And of course, all the other software operations processes, like the deployment without downtime, scaling, monitoring, backup, logs, metrics, all the basic operation stuff. Of course, that we want to have to take care of automatically without having to do any manual steps. I personally believe in open source. So I think a solution to that problem should be open source with open standards. One of the reasons for that is I don't want to have a vendor lock-in, whether it's a cloud provider or an infrastructure provider. I want it to be cloud native and not cloud only. I have a lot of customers, especially in the financial sector, that want to have stuff still on premise. For me, that's okay. I don't care about that. But then I have to be able to deploy that solution to, well, any cloud provider, but also to the customer on-premise infrastructure. And of course, extensible. I know I won't know all my requirements right now, so I want to be able to extend it later on using APIs. And so we've been playing around with Docker for about 7-ish years now. It's an awesome tool for to build and package all my dependencies at compile time, so that I don't have, well, once they're packaged at compile time, I can start the container. They're quick, they're lightweight, and I can actually try out the container and test all the requirements are there, and not rely on stuff to do at runtime, right? It's the same. It's not like a similar container. I should be using the same container for testing and for production, because then I know is what I test is what I get, because it includes all the application code, all the dependencies, all the application server with plugins, modules, libraries, whatever is needed, right? And the description makes it easy to automate, and the tooling makes it easy to use. It enforces the 12-factor app pattern. Unfortunately, I can't see you right now, but I would make a show of hands of who knows the 12-factor app patterns. And if you do not know the 12-factor app patterns, I would make you a short refresher. And of course, the link to the 12-factor app pattern manifesto, which is basically the description how you should build software that's easy to run. And if it's easy to run, it's more stable. And if it's more stable, we're both happier, because you will have a stable software and I will have a stable software to take care of. And boiled down to 5 bullet points, there are of course 12 declarations, is that you should use declarative formats for the setup. So don't make like a script or something, because if there's something is already there, the script will fail. Have a clean portable contract with the underlying operating system, meaning a Docker image, which includes everything down to the libc of whatever you need your application to run, because then you can run that container on any Linux compatible operating system, and you don't have to worry about the version of the server, the version of whatever that's there. You provide everything that's there, or you provide the build pipeline that takes whatever it's there, and the operations are happier as well because everything is there, and you don't need to manage any other requirements around that. To be suitable for deployment on modern cloud platforms means that you don't expect like a certain layout of directories or stuff about that, right? You have your, like in Git, right? You have your local directory, you have recurrent directory, you have all the stuff that is in there, and then you use dependency management to pull in additional stuff, right? To minimize divergence between deployment and production mean to have parameterizable settings, for example, for database and stuff. So you expect it, for example, with an environment variable to be pointed at the correct database, and then the database can make sure to be there and to be available. And to be able to scale up, to scale horizontally without any significant changes in the tooling or architecture. I mean, these are basic, good software quality patterns that I wanted to remind you on, because they make the software operable, and that of course helps us as operations people. Now, the Docker thing that we've been looking at for a long time solves these problems, but does not solve a lot of other operations problems. And so this is the learning cliff of containers from development to production, which they do not include Docker itself does not include security per se. It doesn't include all the operations of running the containers, like service discovery. When the application in container wants to connect to the database, which is outside of the container, how does it find it, which IP, which port, and stuff like that, right? All the monitoring, the deployment is not yet automated. And so for all of that, there's a concept of container orchestration. And the most well-known container orchestrator is Kubernetes. Kubernetes is an open source project. It started at Google originally. Right now there's, 1,200 contributors on GitHub or something. So it's pretty wide, not only Google at all. And so Kubernetes solves the problem of taking a Docker container and starting it on actual servers belonging to the Kubernetes cluster. So you take a set of machines, you install Kubernetes there, you get one API to talk to all the machines. And then, for example, you tell Kubernetes to run this container that you have 5 times. And then Kubernetes will make sure to start your application 5 times and make a load balancer over these 5 instances. And so whenever an instance fails, or crashes, or the machine that it was on goes away, Kubernetes will detect that and start a new instance of your application somewhere else. And so this way, it makes sure that there's enough of your application instances always running. The Kubernetes takes care of the where, on which machine, on which IP port and stuff your application is running on, and also how you as an application can access another service like a database, or if you have like a microservice architecture, another service inside a cluster. And it takes care of all the scaling, load balancing, rolling deployments, persistent storage, and everything else that's needed to make your application inside the container happy and to help it interact with other applications running. Also, it solves the security of isolation, so that's why we're very happy with that. And Kubernetes is something that was published three and a half years ago, something like that. So it's pretty fresh, but currently it powers the biggest web applications in the cloud. Just an example in a picture for you to better understand what's happening here. So I tell Kubernetes in a declarative way the architecture of my application. So for example, I tell it I have my application in a container. You see there's the blue container icon. And I tell Kubernetes, hey, this application, please run it 3 times. And then Kubernetes makes sure that there's a replication controller. And you see there's this lingo of pods, meaning the containers in this case. There's the lingo of the replication controller, which monitors that there's 3 instances all running at all times. And then there is this load balancer, which has port for 3 HTTPS to distribute the requests to the application on these 3 instances of the Docker container running. Same thing with the database, and same thing with the queue service, which I use here as an example. And then I can tell Kubernetes, hey, this application service is the one that I want to make public. So please open a port into firewall or make a public load balancer for me. And then Kubernetes can make sure to talk to the cloud provider API to then actually provision the external access to my application and my application only. So not giving external access to the database or queue service, for example. Kubernetes is like the Linux kernel. It's a technology, right? It's open source, it's code, but there's a long way from taking Linux kernel as the example, from the Linux kernel to make an operating system, right? There's a lot of tooling around that. There's a lot of installers and managers and stuff like that. So that's why there's multiple Linux distributions. And so a distribution packages Kubernetes in this case, with some other tooling around that to make it actually usable. And so the most well-known software distributions are listed here. And also, of course, there's like service distributions where you can they not only take care of distributing Kubernetes, but also running Kubernetes around that. And the link to like a blog post about the differences and similarities between those. You can read on those later. So what OpenShift does as an example distribution of Kubernetes is, you see there the blue containers again with the Docker containers running your application. You see the box around that with Kubernetes managing the containers and the deployment of new containers. And then there you see a lot of stuff around that, which the OpenShift distribution adds to Kubernetes to make it actually usable as to run applications. So for example, it takes care of all the locks, all the metrics on the right side. It brings a load balancer, HA proxy or Nginx. You see on the top, you see all the a build process to actually get your code inside the container to the left, and the web GUI to see and manage it all. That's what the distribution of OpenShift brings to the table. Now, we as Vision, we provide this Kubernetes OpenShift as a service. We run this, of course, on servers on different cloud providers. We take care of all the servers and the load balancers and all that's needed, so that you or anybody else can push a container, and we can take care of the running the container. We take the OpenShift, which includes Kubernetes, which includes Docker. We provide it with the logging, with the Elasticsearch Fluentd Kibana stack. We provide the metrics with Prometheus. We provide the SSL certificates, of course, with Let's Encrypt. We have both the source to image builder, so you only provide code, and we have an already existing PHP Docker image, or you can of course write your own Docker file, so we can build that. We have a Docker registry. There's all the load balancing, scaling, and stuff is of course in there. And then we have different databases that you can either just deploy as a container for yourself, then you manage it yourself, or that we can manage for you separately. And so we can take care of all the backups and monitoring and stuff of the databases and other services for you. We have a concept of resource quotas. That means you get a certain amount of RAM and CPU and persistent storage, and then you can do as many environments or deployments or users as you want. And of course, we provide the 24/7 support and SLA on top of that, both for the platform, but also for the application itself, if you want. We believe that this solves most of the problems that we discussed in the beginning. It helps us to put all the infrastructure configuration, the infrastructure setup to put it as code into Git, which means that once it's in Git, you can version the environment yourself, and you can change the environment. You can make a feature branch yourself, and of course, we can be there to help you with that. But you don't need to wait for us to do it, right? We have a default process for many programming languages like PHP, Python, and so on and so forth. So you could use that, or you can inherit the default process and customize it. I will show an example of that later on. As discussed, you can provide a Docker file, so you can write your own Docker file if you want to, or if you have a very exotic language that we don't have yet. Of course, you can also provide a Docker image, so you can do the build yourself and just push the image if you want. Or you can, of course, write your own builder from scratch. I mean, the world is your oyster. You can do as you wish. And of course, we can provide you the database, or you can use your own database, or you can use the database that the cloud provider provides, like RDS and Amazon. Or, if there's some exotic video transcoding service, or I heard this is a good image service from Liip that's very, very good to use. So, you can use any external service, of course. So you're not locked into any of that. And of course, it's all 100% open source. There's about 60 repos on GitHub from Vision, plus another 20, 30 for Aukia. So it's all open source. And of course, since we use GitLab CI, GitLab and GitLab CI ourselves as well, so do you. It's very well integrated into that. So Aukia is the product from Vision, and Puzzlite is in Bern. We provide you this as a managed service, both in Switzerland. So we have a public cluster running on CloudScale in Zurich, and on Exascale in Geneva, and on Swisscom in Bern. You can choose where you want to be. Of course, we also have share clusters on Amazon, currently in Frankfurt, and I think we have a few private ones in Ireland. Plus, we of course have a region on Azure in Amsterdam. So there you can choose where you want to be, and of course we provide private clusters. So these are the shared ones where you just can start off and play around. And of course, for let's say banking customers, we of course provide private clusters on any infrastructure, including on premise. So the technology, and since it's all open source, of course, you can install it on your laptop as well if you want. We can take care of running that software stack on any infrastructure. And we, of course, also provide, since we're open source community members, we provide back to the community. We have once a month, we have half a day of training, how to use that, how to use Docker, how to use Kubernetes, how to use OpenShift, and they're free. So every other time it's in Zurich, every other month it's in Bern. So this is the service that we provide, starting at 40 Swiss francs a month. I mentioned Kubernetes and I mentioned cloud native. So I want to briefly introduce you to the Cloud Native Computing Foundation. The Cloud Native Computing Foundation is a daughter foundation of the Linux Foundation. So since in the US you need to have a juridical person to do all the legal and trademark stuff, there's of course a foundation for that. In Switzerland, we probably just do an association. That's not a story. You see, there's a lot of stuff on this landscape. And I don't want to go into everything in here. You see Kubernetes on the left, about in the middle. You see all the whether it's Containerd or Rocket or CNI. There's a lot of stuff, and this is all, of course, happening open source, just like the Linux Foundation does its stuff. And so we're very happy to be a member of the Cloud Native Foundation, one of the very few members in Switzerland. And so the things that cloud native computing is about is the containerization, integration into CI/CD, the orchestration and application definition, where Kubernetes comes into play, the observability and analysis, the metrics, the logs, all of that I also mentioned before. Service mesh and discovery, so how do different services talk to each other, and by coordinates Linkerd. The networking, how the actual bits and bytes and streams go back and forth, databases, messaging, how to actually start and run containers, and how to distribute the containers in a cluster. these are like examples of the topics the Cloud Native Computing Foundation deals with. And if that's interesting to you, then please do join our Cloud Native Computing meetup. Next one is the end of August in Zurich. If you have inputs or if there's a talk you want to do, please do fill out the form, and we're happy to welcome you there if that's a passion for you. Are there any questions until now? Or else I will do some demos and some examples for you. Please do chime in at any time. So this is, I hear someone unmuted. Please do speak up if you have a question.
So, yeah, you're aware. Okay, so Liip talk is officially half an hour, so anyone who wants to stay for the demo, stay and stay for half, and then who else can go for lunch. It was really interesting.
If somebody has to leave, then please make a picture of this, because I will show you how it works and what it does. But if you want to try it out yourself, then please make a picture of the voucher code. It's currently limited to 100 accounts, I think, for Leapers. If they're out of accounts, or if you need more, then please just ping me and mention that you heard about it in the Tech Talk. And of course, the links to the chat support. We have a Rocket Chat instance on community.aukia.ch, or we're of course also on the liip.slack.com. Just search for my name and talk to me. And of course, whatever, Twitter, whatever works for you guys, right? So I assume everybody has that memorized or pictured. So I will do some demos. Few people still there? Yay!
Some people still here.
Yay! So let me show you what it is and how it works. Okay, I'm logged in as a user with some quota here, and I want to deploy an application. So there's a lot of ready-made builders and let's say application servers packaged in a Docker container for you. There's from .NET Core, that's the .NET running on Linux, to 3-Sail API Gateway, just an Apache server, packages with like PHP and MySQL, with Django and Postgres, Java, JBoss, Jenkins, MariaDB. You see there's tons and tons of stuff you can just click on and deploy with. Personally, I will do a demo with PHP. This is just a ready-made thing that I can choose which version I want to use. I'm of course going to use 7.0. And I have this really, really complicated PHP application that I want to just use as a demo here to deploy and show you something, how it works. So I told it to get the source code for my application from GitHub. It's open, so I don't need to provide any credentials or stuff. And so what the OpenShift on Aukia will do for you, it will download the source from GitHub. It will make a container out of it. And as soon as the container is ready and pushed, it will start the container and run it for you. So you see here, it's starting, pulling, running. So now you see the application is running. I can go and have a look at meta information. I see it's running on server 33. It has some metrics. Well, not yet because it just started. I can have a look at the output of the container. I can actually like SSH into the container, so to have a look what it's in there. And I can, of course, do all the Linux stuff I want to do for that. And so now that it's started, you see here, it generates a link for me that I can open and have a look at. And you see it's a very, very complicated PHP info application. So that's easy. That's all fun and games, right? But there's some stuff that I want to show you that that make the life for both of you and me easier. So, for example, scaling up the application to 3 servers was a short click on the up arrow, and then you see here now it's running 3 instances. The one we had before, then the one that's running on node 12, and the one that's running on node 34. So suddenly we have a load balancing over multiple instances. It's all there, and if I connect to that URL, I will be automatically load balanced to one of the instances that's running here. Another thing is, you see here it says HTTP. I don't like that. I'm more into SSL kind of or TLS kind of guy. So I open here the external load balancer. I can say actions edit. I can say, hey, please make it secure. I actually want to redirect everything to HTTPS. I can provide my own certificate if you want to, but I can just also accept the default. So it will use the wildcard certificate for a Puyo app. Or if you have your own domain, it will automatically create a Let's Encrypt SSL certificate for you. And now that I click on it, it says sicher, which is secure in German. So now it's all SSL encrypted access to it. So this is how SSL certificates should be handled in 2018, in my personal opinion. Another thing is that for my application, I can have a look at how the application should be deployed. There's a configuration. I can set environment variables with secrets or other configuration like database credentials and stuff. But I can also add an autoscaler. That one I won't do because it's very difficult to demo to add and upload. But I will actually add health checks. So I can say, hey, please check that here slash, or it could be slash health check or whatever you want to do, how much delay I want to wait for initially to check if it's up, and also check every second if the container or my application in the container is happy and healthy. And so saving that, it will create a new deployment, and the new deployment is going to be hitless without downtime. That means I will start a new container of the new version here with the new configuration version, right? It'll take a second to start, right? Pulling. Then we'll start the first instance of the new version. Now it started, but it's not ready. It means that the health check has not completed yet. I think I configured something like 10 seconds. Now the first one is running, and so it kills one of the old ones, right? And starts with starting the second of the new ones. And so that's how you see the deployment will go without any downtime of the application, because it will just swap out one cushion with a container of the new version of the other. And this, of course, happens fully automatically. And then, yeah, after a while, of course, the application still works. Still should give me PHP info. So that's how I think hosting should be done. Any questions?
No questions.
No questions? Please let me show you, to finish off, let me show you like a real, that I know PHP info is a demo, but it's not really like a real application. So this is actually an application running on a Puyo. It's the Pistor Mercante project. And here you see the on GitLab Liip CH, the actual project. In here, it looks just like it is just like any other PHP project, except that it has the .s2i bin directories. And that's actually the way to parameterize and override the assemble, the build step, and to run step. And here you or we can both together provide with how to here compile, or in this case install dependencies for PHP. That's needed to get your application together, and that's of course something you can change and improve on. and the same thing then to run the application. And here in this case, there's like 3 different deployments of the same source code running with different startup parameters to have like different, whether it's a front and a back end or a queue worker instance of the same code. So that's a way to so that this was actually made by Elia, who's also in Zurich attending this talk. So if you have any specific questions about this project, then please do ask him or Tobias, who's also there. Yeah. And with that, I'm happy to answer any questions you might have, or please do try it out yourself. I mean, with that, we hope to give you guys a tool to not only host the difficult, expensive projects, but also to make it easy enough to use for any project or for your hobby projects, so that we can continue to build and improve this process and this tooling together to make it more interesting and more stable for the big customer projects as well.
Thanks a lot. That's really cool. Any questions? No questions. Enjoy lunch, and we'll ping you if we come up with questions.
Yay!